Think about the hours you spend hunting through 20 different open tabs, reading text, copying data, and pasting it into a single summary. Perplexity AI, led by founders like Aravind Srinivas, built the Comet Browser to execute that manual work for you. It operates as an agentic browser, meaning it takes actions on web pages directly. Running autonomous agents requires immense compute capacity. With a $21 billion valuation, Comet relies on strategic backing from hardware leaders like NVIDIA to process these heavy background tasks. Instead of a passive window waiting for your inputs, the browser becomes a digital employee. You give it an objective, and it navigates the web to finish the job. Power users lose a massive portion of their day to context switching. Cross-referencing dense API documentation, hunting for specific error codes, and manually entering data into forms drains time and focus. Agentic browsing solves this mechanical bottleneck. It gives the AI permission to physically click buttons, scroll through pages, and fill out text fields on your behalf. To handle heavier workloads, Comet includes the Perplexity Computer feature. This allows you to assign a multi-step task and let it run in the background for hours without interrupting your active screen. This conceptual graphic outlines the underlying systems that make this possible. First, the Model Council lets you choose between AI models like GPT, Claude, and Sonar based on the task. Then, the Live DOM mapping layer translates the raw website code into distinct actionable buttons the AI can understand. Connecting these specialized models directly to a mapped environment eliminates manual data entry. The system handles the research steps and outputs directly into a clean, formatted document. Let's look at how to execute a technical research task. For this scenario, we are acting as a tech lead who needs to compare the latency of AWS Lambda against Google Cloud Functions. Look at this mock-up of the Comet interface. The smart address bar accepts standard URLs, but it also accepts natural language commands for complex tasks. Before writing the prompt, we open the Model Council menu. Because we are dealing with complex technical documentation, we select Claude 4.6, which excels at coding and technical reasoning. As we write our request into the bar, we type the @tab command. This specific tag forces the AI to only read the documentation we already have open in our tabs. It restricts outside data and prevents hallucinations. Pressing Shift and Enter triggers the action plan overlay. Instead of immediately guessing the answer, Comet lists the exact sequence of steps it intends to take. You review the logic, verify the approach, and hit Approve. Once approved, the Perplexity Computer takes over. It spawns parallel research threads in the background, reading the AWS and Google Cloud documentation sites simultaneously. The final output is generated directly in the browser, a cleanly structured table comparing the exact latency specifications side by side. You can then export this structured data directly into an email draft or calendar invite. A cross-referencing task that usually requires an hour of reading is reduced to a few commands. This adaptability applies across multiple roles. Project managers use these background threads to scan multiple product requirement documents and output a consolidated list of project risks. In this motion graphic, we see a developer utilizing voice mode. By pressing Alt-Shift-V, the browser reads the active screen. You can point at a console error, ask for the fix aloud, and the AI will automatically hunt for the solution in the API documentation. Enterprise leaders can configure background assistants to track pricing changes across 5 competitor websites throughout the week, synthesizing that data into a Friday decision brief. Comet functions as an adaptable worker that clears specific, repetitive bottlenecks regardless of your industry. The recurring challenge with web automation is reliability. When websites update their layouts or use complex, dynamic elements, traditional scrapers fail. This flowchart illustrates how Comet prevents those failures. It starts when a user prompt is routed through the Model Council to select the right processing engine. The code then hits the DOM mapping layer. Here, messy HTML is flattened into typed objects. Instead of struggling to read raw text, the AI sees interactive elements, like a checkout button or a search bar, as distinct callable actions. The execution engine uses this neatly mapped environment to navigate multi-step paths securely. This structural approach ensures the automation remains reliable, even on heavily interactive websites. For knowledge workers, the value proposition is highly measurable. Testing shows up to a 70% reduction in time spent synthesizing data, and the core agent capabilities are entirely accessible through the free tier. The multimodal ecosystem also ensures you avoid vendor lock-in. If a new, highly efficient model releases from an entirely different company, you can route your tasks to it within the Comet interface. There are strict limitations. Agentic actions can still misfire on incredibly heavy JavaScript sites. Mobile users cannot run these processes in the background yet, and the AI layer consumes significantly more RAM and CPU than a minimalist browser. You pay a tax in system resources. But for power users who need to automate hours of repetitive data gathering, the return on that hardware investment is massive. AI tools like this do not replace human expertise. They exist to strip away the digital friction of the internet. By delegating the mindless clicking, scrolling, and formatting to the browser, you protect your time and reserve your focus entirely for high-level decision-making. Drop a comment below and tell me what AI tool or agentic workflow you want to see reviewed next on the channel. I'm Narendra Sin Rathod. Keep building, and I will see you in the next breakdown.